We continue working on the practice for test 2 and now chapter 6 questions. Use the confidence interval to find the margin of error. So for the margin of error, you subtract 0.434 from 0.63 and then divide the answer by 2. For the sample mean, which is the value in the middle, you just add 0.434 plus 0.63 and divide by 2. You are given a sample mean and the population standard deviation. Construct a 90 and 95% confidence interval. If it gives you the population standard deviation, please remember that you must use the z interval. So in this case, if I just bring the calculator up here, stat, you go to tests, and it's a z interval because sigma is given. And you have summary. So what is sigma here? He says for a random sample of 45 business days, the mean closing price of stock is 105.83. Assume that population standard deviation is 10.04. And then X bar is 105.83. N is 45. And now we will need confidence at 90 and 90% and then 95%. So, excuse me, here's the interval. And then now you want to do the 95%, you just go to stat, tests, z interval, and just change 90 to 95. And which interval is wider? The 95% is always wider. And to interpret your intervals, okay, that will be B. You can be 90% confident that the population mean price of the stock is between the bounds of the 90% confidence interval and 95% confidence for the 95% interval. Okay. Next question. Find the minimum sample size needed to estimate the mean for the given values. So there is a formula for n. I'm just gonna type it in here. Okay, so n equals ZC for 90% is 1.645. And then you multiply by sigma, which is 8.7. And then you divide by the margin of error, which is 2. And then you square the results. That's the formula. So if you just do the math, will be 1.645. Oops, I got 0.645. 1.645. That's 90. That's a critical value for 90%. Times 8.7. Then divide by 2. And then you need to square this number. And you need to round up, so the answer will be 52. So when you input your answer right there, you just put n equals 52. Find the critical value. Let me just open the table here. 90% and sample size 29. You need degrees of freedom, which is 29 minus 1, 28. So just look up for 90 and 28, guys. There's the 28. 90 is the second one. And the 28 is right here. 1.701. In a random sample of 8 people, the mean driving distance to work was 25.2 miles, so that's X bar. And the standard deviation was 4.5 miles. And it's not the population standard deviation, he's referring to a sample, so that's S. Assume that the population is normally distributed and use the t-distribution. Well, actually, with this assay, you have to use t-distribution to find the margin of error and construct a 99% confidence interval. Here's what you can do, guys. You can just actually find the interval first. Let me show you. So go to stat, t-interval. It's not a z because he gives you a sample standard deviation. And let's see. The mean was 25.2. Standard deviation is 4.5. Now, what was the sample size? 8 people, so n is 8. And the confidence level is 99%. So this is the interval, guys. Now to find the margin of error, here's how you do it. You do 30. Oops, I need to go back because I forgot what I had there. The interval. So 30.768 minus 19.632. 30.768 minus 19.362. That should be a 30 there. I need to insert 30.7 30.768 minus, if I remember, 19.362. Okay, and then you divide by 2. So that's the margin of error. If you don't want to use the formula E equals TC S over square root of n, you can do that. So the margin of error is 5.703, and you already have the interval. Okay, since it is miles, it's gonna be, and you just put the answer. Construct a 99% confidence interval. You already done that. Here's the interval one more time. Stat, tests, t-interval. We've done it already. We have it there. 19.632, and I probably put 362 there, but that's and 30.768. So you just put 19.632 right here and 30.768. Interpretation, it can be said with 99% confidence. Okay, let's see. Okay, here, this is it, the C. With 99% confidence, it can be said that the population mean driven distance to work in miles is between the intervals and the point. Next question. The state test score for 12 randomly selected high school seniors are shown below. Complete parts A through C. We can do this using the calculator or using StatCrunch. I'm going to do it both ways. So you enter the data in L1. I put the data in L1, and then he wants, first of all, X bar and S. This is from chapter 2, guys. To find X bar and S, you just go calc one variable statistic. L1 frequency list should be empty, and hit calculate. And the first one is X bar, which is 909.92, and S, which is the sample standard deviation, 303.962. So that is the sample mean and the sample standard deviation. Construct a 99% confidence interval. You just go to stat, tests, t-test. If it doesn't give you sigma, it's a t-interval always. So press enter. Data, you have to select data this time because you have the data set. I put my data in L1 and I need 99% confidence. And you guys, you could have done the interval and you will get X bar and S as well. So this is the interval, 637.39 to 1182.4. That's X bar, the sample mean, and that's S. Use a standard normal distribution or a t-distribution to construct a 95% confidence interval for the population mean. Justify your answer. If neither distribution can be used, explain why. In a random sample of 44 people, the mean body mass index was 27.8 and the standard deviation was 6.14. Okay, since he gives me a sample size more than 30, he didn't mention that the population is normally distributed. It doesn't have to be because the sample size is more than 30. He gives me X bar 27.8 and S 6.14, so we use t-distribution, which is here. Find the interval. Here's how you do the interval. So you just go to stat, tests, t interval. It's not data, it's a summary now. So I go to stats again. Okay, what is X bar here? The mean index was 27.8. S is 6.14 and the sample size, guys, is 44. As long as the sample size is more than 30, the population doesn't have to be bell-shaped. And he wants what confidence level? 95%. Okay, that's the interval, 25.933 and 29.667. Okay, I wanted to go back to the previous question, show you that we could have done that using static crunch. Yes, one, so you could have opened that in static crunch. Let me just show you. And then you go to stat, t stats, because we're doing t statistics, t distribution, one sample with data. You select the sample. And the question was to find 99% confidence interval. Look what you do, guys. It's just do right here, confidence interval, and put the confidence level. And just hit compute. And watch as the confidence interval that we did using the calculator. Not only you get the confidence interval, you get the mean and you get the standard deviation, the sample mean, and you get the standard deviation if you want. That's the degrees of freedom, 12 minus 1. So you could use stat crunch as well. Okay, use the standard normal or the t-distribution, construct a 99% confidence interval. In a recent season, the population standard deviation. So he says we know the population standard deviation, guys. So if you do this using your calculator, you will have to input this data into L1 and use Z interval, not T interval, and input sigma is 1.27. But look how you can do this with stat crunch. This is the data. You go to stat, Z stat, because he gave me sigma. One sample with data, and look, this is where you enter the value of the standard deviation. And what was the value of the standard deviation here? 1.27. Let me just get him back. So you put 1.27 right here. And then confidence level, whatever, 95%, and hit compute. Oh, we didn't select the column. And you get the interval, lower limit, upper limit. If you are to do this with the calculator, guys, you have to input the data in L1 first of all. So all of those values you have to type in L1, and then you go to stat, Z interval, choose data because you have data now, a summary, and make sure to enter the value of sigma, which is 1.27. If you put your data in L1, keep the frequency, never change it. Select the confidence level, which is, he says, what confidence level? 99%. So just make it 99% here, and then hit calculate, and then you get your interval. Let P the population proportion. Of 993 children surveyed, 135 plan to join armed forces in the future. What's the point estimate for P? We call it P hat, which is X over N. And when you do the math, it will be equal to X is 135 divided by N is 993. And you just do the math and get the answer. And let's see what the answer would be. So let me clear here. 135 divided by 993. .134 if he says 3 decimal places, so the answer should be 1.36. So this answer right here should be 1.36. Q hat, guys, is 1 minus P hat. So whatever answer you get in the first one, you just subtract it from 1. So it will be 1 minus 0.136. And you just do the math and get the answer. In a survey of 2,914 adults, 11350 say that they have started paying bills online in the last year. 99% confidence. It's a proportion Z interval. So if I bring the calculator back, you go to stat. If you remember, it's a letter, I think, A. 1 prop Z interval. You enter the value of X, which is 1450. You enter the value of N, which is 2914. You enter the confidence level, which is 99, and hit calculate. And here you go. 0.4737 and 0.5215. And how do you interpret your results? With it's not about the sample proportion, it's about the population proportion, so it will be C. Okay? So that is the answer. And you put just the lower end, the upper end, and it says 3 decimal places. In a survey of 2008 adults in a recent year, 724 made a New Year resolution. Find a 90% confidence interval, guys. It's a 1 prop Z interval, should be very easy. And just go to Z prop Z interval. Okay, so X is 724. N is 2008. Confidence level, first of all, he wants the 90%. And here you go. 343,378. So the 90% confidence interval proportion is 0.343, and then you change it to 95%. The 95% is always the wider one. It's always wider. The higher the confidence level, the wider the interval. Here, population proportion between the endpoints of the given interval. A researcher wishes to estimate with 90% confidence the population proportion of adults who support labeling legislation for genetically modified organisms. Her estimate must be accurate within 7% of the true proportion. 7% is your margin of error, guys. No preliminary estimate is available. Find the minimum sample size. So here's the formula. If there is no preliminary estimate is available, you use p hat 0.5 times q hat 0.5 times. You open a parenthesis, you put the critical value of 90%, which is 1.645, and divide it by the margin of error 0.07, and then you square the whole thing. Okay. That's the formula that you need to use. And you round up your answer. Now for B, find the minimum sample size needed using a prior study that found that 80% of the respondents said they support labeling legislation for GMOs. So now we know p hat is 80, so it's 0.80 times q hat will be 0.20 times the same thing as we did above, 1.645, that's for 90% confidence, divided by 0.07, and close this one and then square. So you just compute both formulas to get the results. Always when you have preliminary estimate, you have smaller sample size. So reduces, having an estimate of the population proportion reduces the minimum sample size needed. All right, so that concludes the questions from chapter 6. Stop here and then provide another video for chapter 7.